All right, welcome back. This is our last chance to check in with climate. So we started looking at climate in the last unit on sustainability. Now we're looking at climate under the umbrella of challenges to globalization. So in order to facilitate a look at climate, I have some things lined up for you, and we should be able to cover them all before the lunch break. So after lunch, we can move on to a different topic. So to begin our discussion on climate, we have this cartoon, and I think you can see the ideological perspective of the cartoonist quite quickly. The ideological perspective of the cartoonist is being presented to you through the reaction of the people in the crowd. So what if it's a big hoax and we create a better world for nothing? So it's the ideological perspective is really about the simplicity of this argument and the idea that they're acknowledging we're going to create a better world, but creating a better world for nothing. You can see that the cartoonist is in favor of changing the human interactions with the environment to try to have more green jobs, livable cities, renewables, clean water, because we are creating a better world. That this person is being criticized for being too simple by not seeing how it's going to benefit us. So we're about to take a look at climate change, and one way to kind of grab our attention is here's a news article from 2019, and what a great headline that is. You know, this is from 2019, so this has nothing to do with COVID-19. This is from June, before COVID-19 was, at least that we were aware that it was out there. And it says high likelihood of human civilization coming to an end by 2050. So isn't that uplifting? Isn't that very hopeful? And when you read through the article, it's linking our ecological footprint, our destruction of the biosphere, our contamination of that thin livable space as an externality of our global economic activities. And this is just another article that is suggesting that mankind by nature has created its own doomsday machine, its own doomsday device. That we are going to be that species that creates its own extinction. So this article kind of gets our attention with regards to climate change and the significance of it. So what is the significance in your essay that you're writing? What's the significance of responding to the challenges of 2020? What's the significance of responding to the challenges within the global village? Well, some would suggest that if we don't, civilization will come to an end within our lifetime. So that's the significance. And I think that in the analysis of the source, there's room to explore the significance of the topic in an A2. So this article is linked to the lesson for today. So I would highly recommend a quick little read through at your leisure. And you'll see some evidence being used to quantify their position, their argument. And this is the type of evidence that you may be able to bleed into your essay. So after the lunch break, if we have some time with the computers, maybe it might be a good time for you to take a peek at that article. Another article that I have here for you is a poll of Canadians, and they asked Canadians, you know, what are we worried about right now? And again, this was before COVID-19, so you're not going to see pandemics or public health in the sense of pandemics, although healthcare was the number one concern. You can see that climate change was among these the least concerning. That they're more concerned about taxes, more concerned about unemployment, more concerned about the economy. So based upon this, in that classic struggle between the economic prosperity and development and growth, between the environmental cost, it looks like Canadians, who were polled at least, would put economic growth ahead of the environmental cost. So maybe we're not ready yet to deal with the environmental doomsday machine that we've created. So this is another article that you might want to flip through just to see, you know, why is it that Canadians are not seeing the global concern that scientists are expressing here. They're saying it's the end of the world. These guys are saying, you know what, I'm more concerned about healthcare. I'm more concerned about taxes. I'm more concerned about immigration than I am about climate change. So there is definitely a disconnect here between those two. Next up, we're going to watch a quick 4-minute video to get us started with this topic on climate change. And then we have a feature presentation, a 20-minute video. Maybe you recognize this guy with a hat. Maybe you've seen him in a science class before. But this is the single best video I've ever seen on climate change. And that's how we'll wrap it up before the lunch break. So we're going to go to the kind of the introduction video. It's kind of like the coming attractions. It's more concise to kind of get your attention. And then we'll go to the feature speaker. So the topic is climate change. We'll go through these two things before lunch. After lunch, I believe we have the Chromebooks, and then you can wrestle with those websites and some other stuff too. All right, here we go.
For most of us, 2 degrees Celsius is a tiny difference in temperature, not even enough to make you crack a window. But scientists have warned that as CO2 levels in the atmosphere rise, an increase in the Earth's temperature by even this amount can lead to catastrophic effects all over the world. How can such a small, measurable change in one factor lead to massive and unpredictable changes in other factors? The answer lies in the concept of a mathematical tipping point, which we can understand through the familiar game of billiards. The basic rule of billiard motion is that a ball will go straight until it hits a wall, then bounce off at an angle equal to its incoming angle. For simplicity's sake, we'll assume that there is no friction, so balls can keep moving indefinitely. And to simplify the situation further, let's look at what happens with only one ball on a perfectly circular table. As the ball is struck and begins to move according to the rules, it follows a neat, star-shaped pattern. If we start the ball at different locations, or strike it at different angles, some details of the pattern change, but its overall form remains the same. With a few test runs and some basic mathematical modeling, we can even predict a ball's path before it starts moving, simply based on its starting conditions. But what would happen if we made a minor change in the table's shape by pulling it apart a bit and inserting 2 small straight edges along the top and bottom? We can see that as the ball bounces off the flat sides, it begins to move all over the table. The ball is still obeying the same rules of billiard motion, but the resulting movement no longer follows any recognizable pattern. With only a small change to the constraints under which the system operates, we have shifted the billiard motion from behaving in a stable and predictable fashion to fluctuating wildly, thus creating what mathematicians call chaotic motion. Inserting the straight edges into the table acts as a tipping point, switching the system's behavior from one type of behavior, regular, to another type of behavior, chaotic. So what implications does this simple example have for the much more complicated reality of the Earth's climate? We can think of the shape of the table as being analogous to the CO2 level and Earth's average temperature, constraints that impact the system's performance in the form of the ball's motion or the climate's behavior. During the past 10,000 years, the fairly constant CO2 atmospheric concentration of 270 parts per million kept the climate within a self-stabilizing pattern, fairly regular and hospitable to human life. But with CO2 levels now at 400 parts per million, and predicted to rise to between 500 and 800 parts per million over the coming century, we may reach a tipping point where even a small additional change in the global average temperature would have the same effect as changing the shape of the table, leading to a dangerous shift in the climate's behavior, with more extreme and intense weather events, less predictability, and most importantly, less hospitability to human life. The hypothetical models that mathematicians study in detail may not always look like actual situations, but they can provide a framework and a way of thinking that can be applied to help understand the more complex problems of the real world. In this case, understanding how slight changes in the constraints impacting a system can have massive impacts gives us a greater appreciation for predicting the dangers that we cannot immediately perceive with our own senses. Because once the results do become visible, it may already